creates a real challenge to get across, stops momentum, stops the speed of the advance. So we define a wide wet gap as an obstacle over 40 metres. To achieve and get across that, you need a really niche capability.
The gaps are currently surveyed by very specialist recce engineer teams.
And that exposes them to greater risk from the environment that they're working with, but also from the enemy that they face.
They're using quite rudimentary kits such as rowboats, string.
If we can do that by an autonomous means, it doesn't expose them to that risk. We're using unmanned ground vehicles, aerial systems, really capitalising on industry innovation.
Through our colleagues in DASA, we were able to get 5 suppliers involved in the challenge, and they range from America to Norway and 3 suppliers in the UK.
So we were really pleased with the quantity of proposals that were received, and it was really quite a difficult job to down select them to the 5 that we took forward.
The solution that we propose is based on our unmanned platform. That is, it's a drone with high endurance flight time.
An amphibious bottom crawler with some off-the-shelf sensor payloads and also some developmental technology in terms of an autonomous penetrometer to measure soil strength.
This is a surface vessel. It drives to the river. As it enters the river, it then switches over to twin electric thrusters to propel itself through the water to the other side. It uses high-resolution sonars, high-resolution lasers.
So our particular solution is based on radio frequency imaging and measurements of metrics. We're using these radio waves fired into the ground. We proposed a solution that's very lightweight and low power that can be mounted on a drone.
This platform here is incredibly robust. It has got a huge capacity for additional sensors in terms of weight and power. When we reach an obstacle in the water, instead of having to skirt around it, we can push through it.
The Map the Gap not only is about taking those measurements at the gap remotely, but also autonomously.
The vehicle is given the start command, it's told where it is to start with, and off it goes and performs that mission.
The user can specify areas of interest with a couple of clicks to define boxes, and then we use satellite data to calculate routes to scan along the river.
Of course, it needs to be fit for a military environment. It needs to be robust. It needs to be able to be put in the back of armoured vehicles. It needs to be compact.
You know, it can be a very elegant, exquisite solution in terms of technology, but it has to work in the field.
When you're operating in a wet gap environment, it could be any kind of wet gap. It could be a very small gap. It could be a very wide gap. Going into the water and coming out of the water, the banks can be very steep. All sorts of conditions that you may come up against.
Our solution was based in different technologies, right? That independently they work fine. When you want to try and integrate both of them all together, there are always challenges.
The Map the Gap prevents those highly skilled recce engineer teams even being in the water or at the gap crossing.
Improving the quality of the decision making made, as well as bringing speed and tempo to the battlefield.
Map the Gap has been a really interesting project for us and one we've really enjoyed delivering for DSTL.
What's not to like about playing with robots and
Technically, it's fascinating. It's absolutely fascinating. It's like a red rag to a bull for me. I love coming up with interesting solutions.
Yeah, it's been a real eye-opener to see what's out there. Some really brilliant solutions that we've been offered.
The real joy that we get out of it is applying this technology to things for the real world that the warfighter can use and that will benefit them and save lives. It's, you know, our privilege to be able to bring that kind of capability to them.